All right, let's roll. 3.2, day 3. Hopefully you're still with me. Hopefully things are still going okay. We talk about extracting square roots. Hopefully that's okay. We then talked about completing the square. And then after that, we talked about the quadratic formula. So today, I'm going to continue to build on that. And I'm going to take what we've done previously in this class and kind of build it onto what we're doing currently. So hopefully you're not losing any of the stuff that we've done previously in the past. So I want you to take a look. We've done this before. You have this function here. I ask you, where is f of x greater than or equal to 0? Where is f of x less than 0? So if you think, where is y greater than or equal to 0? We used those colored pencils, and that kind of helped us out. So I'm going to use green, and where is y greater than or equal to 0? That would be those two pieces that are above the x-axis. Where is f of x less than 0? Obviously, that's going to be, I'm going to use orange. That's going to be my piece below the x-axis. So think, how would I write those answers? You should be saying to yourself, interval notation. We also want to use the x values when we're talking about them because we're already given the y values. That must mean we have to use the x values to answer the question. How do I write where f of x is greater than or equal to 0? How do I write that left-hand piece? How do I write that right-hand piece? Hopefully you're remembering there is my interval notation. I'm using brackets because it's greater than or equal to 0. So then how do I do where it's less than 0? Think x values, all parentheses because it's strictly less than 0. It looks like that would be my answer. We've done that already. That's kind of what we did in chapter 2. So hopefully that was a good refresher because now I'm going to build on that. Example 4. I ask you to take that function right there, x squared plus x minus 6, and figure out where that thing is greater than 0. All right, so first thing I got to do, if you remember, if I go back to the last picture, the key pieces of information were finding these points right here. I gotta find them because I know that those are going to be in my answer. So if I go back and I think about this, well, now I don't know where those points cross the x-axis. So I gotta figure out what x is. How do I figure that out? Well, I'm going to factor this. Two numbers that multiply to get -6, but add to get +1. It's +3 and -2. So I factored them. I want to figure out where that thing is greater than 0. Here's what I kind of do from here. Here's what I'm thinking. So x plus 3, what makes that 0? Well, it's -3. X minus 2, what makes that 0? Well, it's +2. There are the points where it crosses the x-axis. So I'm going to plot those 2 points. All right, so think, parent function. I know this is x squared. I know x squared looks like a parabola. The leading coefficient, this number right here, tells me whether my parabola is going to open up or down. Because that's positive, I know my parabola is going to open up. I only need to do a sketch. I don't need to know exacts because I know those 2 points are exact. The other points are irrelevant because those are the important pieces of information when I write my interval notation. So if I think I know my parabola opens up, there is my sketch. So I'm asking you, where is this greater than 0? Well, I think greater than 0, you would shade those two spots right there. How do I write that in interval notation? And it looks like there is my answer. Okay, letter B. First thing I notice, think about when we did quadratic formula. It always had to be equal to 0 first. Well, in this case, it has to be less than or equal to 0. All right, so I moved that positive 9 to the other side, so it's minus. From here, I'm guessing this is going to be where you're going to have questions. You cannot have that negative out front when factoring, so what I'm going to do is actually factor that negative out. When I factor the negative out, the negative x squared becomes positive, the positive 6x becomes negative, the negative 9 becomes positive 9. I basically just changed all of those signs. Okay, now I can factor it from here. Two numbers that multiply to get positive 9, add to get negative 6. Well, it's negative 3 and negative 3. I'm going to clean that up a little bit. I'm going to write x minus 3 squared. Think what makes that 0? Well, I think what makes that 0 is positive 3. So I'm going to plot that point positive 3. Look at your leading coefficient. Your leading coefficient is negative. So I know this parabola has to open down. Because there is only one point where this crosses my x-axis, I know that has to be the vertex. Hopefully that makes sense to you. If there are 2 points, obviously the parabola needs to go through those 2 points. Because there's only one point, I know it has to be the vertex, and it's always going to work that way. Okay, so there is my parabola. I want to know where it's less than or equal to 0, so I shaded everything because that's where it's less than or equal to 0. So it looks like everything is shaded. How do I write that in interval notation? Well, I write negative infinity, comma, infinity. It's below everywhere. Hopefully, that made sense for you. So think, build upon what we did, where it's greater than 0 would be above the x-axis, where it's less than 0 would be below the x-axis. Factoring, I'm guessing we might need some practice with that. I'll be ready for that if we do. And interval notation, hopefully you still remember all of that.